Okay, let's look at this limit question that has been troubling us. We are supposed to find the limit of the expression x raised to the power 4 minus 3x squared plus 2 over x cubed minus 5x squared plus 3x plus 1 as x approaches 1. With all limit question, we'll try direct substitution and see whether it will work. And we'll concentrate on the denominator. The denominator is x cubed minus 5x squared plus 3x plus 1. Let's see whether direct substitution will turn the denominator to 0. When x is 1, we shall have, when x is equal to 1, we shall have 1 cubed minus 5x squared plus 3, 5 1 squared plus 3 multiplying 1 plus 1. This will turn to 1 minus 5 plus 3 plus 1. And the whole thing will become 0. It means direct substitution cannot work in this case. So what we have to do is to simplify the expression further. We will do that by factorizing the denominator and the numerator. So let's factorize the denominator and the numerator. We will start with the numerator. The numerator is x raised to the power 4 minus 3x squared plus 2. To factorize this, we use what we call the factor theory. We use the factor theory. We'll check for numbers that when you slot into the function will turn 0. And that will lead us to one of the factors of this expression. And normally we do try and error with numbers. In order to limit your trials, we'll test, normally we test the factors of the constants. So the factors of the constants are 1 and 2. So let's test when x is equal to 1. When x is equal to 1, x raised to the power 4, 1 raised to the power 4, 1 raised to the power 4 minus 3, 1 squared plus 2. This will be the expression. We have 1 minus 3 plus 2, and this will turn 0. This means that this is one of the solutions or the roots of this expression. So 1 is the root of this expression. Since s is equal to 1 is one of the solutions of the expression, the 1 can cross the equal sign to become s minus 1 is equal to 0. And this implies s minus 1 is a factor to this expression. If it's really a factor of any number is a number that can divide the bigger number without a remainder. So it means this s minus 1 can divide this expression without a remainder. So we perform the division by using the long division approach. S minus 1. Use the long division to divide this expression so that we'll get the second factor to x minus 1. So let's write the expression here. X raised to the power 4 plus 0x cubed. I want to write the expression in descending powers of x. In descending power of x. So we don't have s cubed. So that's why I'm replacing that gap with 0x cubed. Then minus 3x squared. Then plus 0x. We don't have x a term in x. So I'm also replacing that gap with what? 0x. Then plus 2. Okay. Then let's start with the long division. Let's start with the long division. Let's go into x raised to the power 4 x cubed times. So write it here. Then we'll multiply back. We'll have x cubed times x will give us x to the power 4. And this multiplying this will give us minus s cubed. Then we'll perform the first subtraction. Our 2 comes here. Then have our 0x. Then have our minus 3x. This is the reason why we normally replace that gap. So this will have a counterpart to subtract. 0 minus minus 1 become plus. So this one become positive x cubed. Then this one will drop. The s with the power 4 will drop. Then s goes into x cubed, x squared times. Then will multiply. It will give us x cubed, but this time it will give us minus x squared. This should have been x squared. Minus x squared. Then perform another subtraction. This will come here 2. This will come here 0x. And then minus 3x squared minus x squared. To give us minus 3x squared plus x squared. And to give us minus 2x squared. Good. Then continue our division. X goes here minus 2x times. Then we multiply back. We are going to get minus 2x squared. And this time this will give us plus 2x. Then we subtract again. We have 2. 0 minus minus 2 give us minus 2x. And this minus this will drop. And x going to x how many times? 2 times. So minus 2 times. We multiply back minus 2 times x give us minus 2x. And minus 2 times negative 1 give us positive 2. When we subtract, everything drops. So this tells us that x minus 1 is really a factor. So now the first factorization will be x minus 1. Then x minus 1. Then we'll copy the quotient. And that will be x cubed plus x squared minus 2x minus 2. This is a cubic function. We can decide to also factorize further. Mhm. Factorize further. We can do that by still using the factor theorem. So let's copy that one out. X cubed plus x squared minus 2x minus 2. So the factors of 2 are still 2 and 1. So we can do try and error for 2 and 1 to see which one will give us 0. So it doesn't work. We can try negative 1 and negative 2 and see which one will give us 0. Try and error. So I'm trying negative 1 first. Try and error. So negative 1 cubed plus negative 1 squared minus 2 multiply negative 1 minus 2. So this will give us negative 1 plus 1. And this will give us positive 2 minus 2. And this tends to 0. So this is when s is equal to what? Negative 1. Good. It means s is equal to negative 1 is one of the solutions. When negative 1 cross the equal sign, we'll have s plus 1 is equal to 0. It means s plus 1 is another factor of this expression or even the original expression. Since this is a factor of this is also a factor of the original expression. So now let's divide this one by this to get the other factors. We are going to perform long division again. Let me shift this one to the right side small, the left side small. And then we perform the long division. This s plus 1 is a factor of s cubed plus x squared minus 2x minus 2. This one there is no gap, so the expression is already in descending powers of x. X going to x cubed x squared times. When I multiply back, I'll get my s cubed. This time this will give me x squared. Then I perform my subtraction. Minus 2, then minus 2x. These two will drop. Let's go into minus 2 x how many times? Minus 2 times. I multiply back, I'll get minus 2x. I multiply here, I'll get minus 2. Then it is off. It means this expression alone can also be written as s plus 1, s plus 2. So s minus 2, x squared minus 2, x squared minus 2. Good. In that instance, it means the numerator can be simplified to x plus 1, x minus 1, s squared minus 2. That's the factorized form of the numerator. Let's put that aside and now go to the denominator. Mm. The denominator is x cubed minus 5x squared plus 3x plus 1. Let's do that one here. X cubed minus 5x squared plus 3x plus 1. So we'll use a factor theorem as well and see if we can have a factor to this expression. Using the factor theorem, we take the factors of 1. We will manipulate the factors of 1. So the factors of 1 is actually having only one factor, that is factor itself. So we'll test -1 and 1. The one that will give us 0, we need a factor. So let me test positive 1 first. So 1 cube minus 5 times 1 squared plus 3 times 1 plus 1. This will give us 1. Even we can see from the first test that is 0. So let's not waste time. So when s is equal to 1, s is equal to 1 is a solution of this expression if it is stated as a notation form. So it means s minus 1 is really a factor. We are going to perform long division of x minus 1. So x minus 1 is going to divide the expression s cubed minus 5x squared plus 3x plus 1. This one goes here, x squared times. We multiply back, we get x cubed. We multiply here back, we get minus x squared. Then plus 3x plus 1. Good. Oh, sorry, not plus 3x plus 1. So, where's my eraser? This is not part. Okay, so we are coming to perform the subtraction. The 1 will come here, plus 3x. Then this minus this become plus, so become minus 4x squared. Then x goes into 4 minus 4x squared, we get minus 4x times. This goes here. This time this will give us minus 4x squared. But this time this will give us plus 4x. Then perform another subtraction. This will give us 1. This and this will give us negative x. And this 2 will drop, cancel out. Let's go into minus x negative 1 times. And I multiply back to get minus x. And this will give me plus 1. And this will drop. So the factorized form for the denominator become x minus 1, x squared minus 4x minus 1. If you look at this expression, you can't factorize this quadratic expression. I can never factorize further. Good, good. Now, it means now our limit is now reduced into the form x minus 1, x plus 1, x squared minus 2. That's the factorized form of the numerator. The numerator is x minus 1, x squared minus 4x minus 1 as x approaches 1. So this will cancel out this. Then the remaining expression will be a limit x plus 1, then x squared minus 2 all over x squared minus 4x minus 1 as x approaches 1. Then we can perform our substitution here. So it will be 1 plus 1, 1 squared minus 2 all over 1 squared minus 4 times 1 minus 1. Simplifying further, we'll have 2 in this bracket. Then multiply negative 1 all over 1 minus 4 minus 1. And this will turn into negative 2 over negative 4. I think so. Yeah, negative 4. and this will translate into what? Positive half. That is the limit of this expression as the expression as it approaches infinity. Thank you very much for watching. Don't forget to subscribe to my YouTube channel. Thank you.